Hey everybody. Let me just get some stuff set up here. Oh wait, you're trying to tell me I'm already casting? Oh no. There we go. Cool, and then let me go ping the Discord, and then we'll wait just a couple minutes for people to get on. Cool. Hopefully some people will trickle in here. Yeah, cool. We'll give it one more minute and then we'll start. So. Yeah, so we got all this stuff done yesterday, right? So I'm thinking I can just... Any of this stuff I need to... So we didn't already have any of this or any of this. I already removed unit. We're not even parsing this stuff yet. We don't have to worry about that yet. We're not doing those. Don't have a formatter yet. We don't have array types yet. I already reviewed the PR. Yeah, so none of this is stuff I need to do today. This is all done. So pretty much I can just start taking our IR, I think, and making assembly. Trying to run it. So sounds pretty fun. Hello, Anand Varma. Not sure if I'm saying your name right, but probably not. So yeah, codegen it is then, right? I wonder... Yeah. I kind of want to start this again, because I don't think I'm going to use a lot of that, because now that we have an IR, that kind of changes. Yeah, I pretty much want to start this from scratch, actually. Because the way I had started building this a while ago was like from the checker. Now we're coming from an IR, right? So, hey, William. Yeah, let's start. Let's start this. So, what... Yeah, how does this codegen module work? By the way, are tests even passing? No, they're not. Because I forgot to do this last time, so that's okay. from when I removed those units, I think. Okay. There we go. Okay, there we go. Now we're in a better starting place. So, hey, what are you doing today? I think we're going to try to actually generate some ASM and be able to run some lovely executables, is the hope, Mr. Glick. Are you going to make your own backend? Yep, that's what we've been doing, and we'll be doing more of today. Hey, Saba Bugs. So a codegen needs to take in, I guess it'll have, what's our CLI look like right now? Still a little bit sick, so a little bit stuffy and might cough a few times, but yeah, okay. Hey, Stefan. Do you have a concrete goal, or do you plan to progress as much as possible? I'd be very happy if we got anything actually running. That's not a very concrete goal, though, and I think we'll get past just anything running, so. No, I don't really have a concrete goal. I'll just go until we hit a good stopping point. Thank you, William. Okay, so what are we getting out of this IR, right? We've got IR generator. It's got add var, lookup var, get ID, add block. Program IR, right? This is kind of like the, oops, the magic one. Does this actually need to be pub? No, I don't think so. Okay. Turns a vec of basic blocks. Gotcha. So yeah, let's have like an impl. Any syntax changes? Yeah, there were some syntax changes yesterday, just some minor ones. I wouldn't say any of them were like huge. Yeah, and most of it was for stuff that we haven't actually implemented yet, so we'll talk a bunch about it once we're actually implementing it. So this will have like, I don't know, 2x 86 64 ASM, right? Or NASM, I guess would be better. Takes an IR, which is a vec of basic blocks, and we'll return a string, I guess. Basic block is not a thing, so make that pub. I should fix this. There we go. And should be able to pass this by reference. Should take a slice, says Clippy. Sure, we can make it take a slice. Okay. And yeah, so I guess we'll just loop through. I'll say like let asm I'll say let lines be vec. Hello there. Quera. Let lines equal vec, a new vec, and then ours should be mut, no? Wait, how many of you guys say mut and how many of you say mute? Because I was told yesterday that many people say mute, and I've always said, actually I think I maybe used to say mute, and then I switched to mut at some point. But now I say mut, let mut. It is mutable, so mute makes sense. You used to say mut, now definitely mute. You call mut mud? Well, there you go. So this is mute. Okay. So I'll say like for an IR. So this should be a basic block, right? Okay. You say mut, name free. Well, moot is an option. There you go. Trying to think how best to architect this. What if I had like a trait? I feel like a trait would be nice here. Like what if I had a trait that was like 2asm that had a function 2x86 64 nasm that takes self and returns a string. And then I just have to implement this for those things. So like impl 2asm for basic block. Right, so then I can say lines.push block.to that. And then we return lines.join with new lines. It's pretty basic. And then so what are basic blocks made up of? Label and instructions, right? Okay. So we'll say like let lines something like this again. Then here we'll say like lines oops. So we have the label and then for instruction in self.instructions, which is a vec of instructions. We should lead by reference. So we should also impl 2asm to asm for instruction. So we could say lines.push format well, there we go. Right, something like that. And then add a new line at the end. So just an empty line. Cool. So that should work. And then okay, so there's that. Let's set up our, let me make a nice simple get rid of that and that. Although I guess we're doing 3 spaces now, aren't we? And okay, that's probably a little too complicated. What if I just have this? Or I'll have alright, here's our program, right? So I should be able to make an IR for this thing. I forgot to specify that this returns an int. You could set up NeoVim to use 3 spaces automatically in .lv files. Oh, that'd be nice. That'd be really nice. Although part of me thinks that I must have been like high or something when I made that decision, because 3 is ridiculous. Alright, so here we go. There's that. Just leave it to the user? Yeah, for sure it'll be left to the user. But I mean, there needs to be a default, so I don't know what it'll be. So then let's go to main here. So we have the IR string. We're not going to use this IR string anymore. Let asm. Oh, okay. So I need like a new codegen, right? New that's kind of useless, but okay. How many years does it usually take to fully build a new programming language from scratch? I wouldn't know, and it's hard to say like what's fully built, you know? And so that's kind of a complicated question because nothing's ever really done. JavaScript, they say, was made in 10 days. But then JavaScript has also been in development since then for the last however many years, right? So, like, would you say JavaScript is done? I don't know. I wouldn't really say JavaScript is done yet, so. Codegener. Let asm equal I thought I made that this. Why is this? Wait, what's wrong with this? Oh, the trait isn't in scope. That's probably why. No, I mean, that's not what I meant. I meant, where's the trait? This thing. Wait, what? Oh. Wait. Oh. I see. Doesn't really need self though, unless you made new start. Yeah, what if we just got rid of this and did this? And then we don't need to do that, we can just do this. And then this just takes the IR. There we go. And then is this a string? Yeah, so that should be pretty basic. Perfect. Let's try this. So we get these labels, instruction, 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 instruction. Perfect. So then we just need to make this a little bit better, right? So this is an instruction, so we can match. And yeah, make these all to-dos. So this is like add, sub, mul, div, not, assign, conditional, call, go to, return, and exit. Okay. So see which of those to do first. Assign, right? So okay, how do we do assign? That's the question. Yeah, this is where it starts getting more complicated, isn't it? So okay, let me find our example. Could we just do this? We still run into an assign. Oh, because of this. What if I just had this? Then we just have an add. Okay. So we kind of just need to like stick that in a temporary place or register, right? So I need some sort of convention for where I stick these temporary values, right? Are cons going to be optimized out of compile time, or is it just going to be read-only memory? I don't really know. For now, we'll do whichever one is easy, which I guess would be read-only memory, right? So it sort of depends on the destination, right? Um, hmm. Okay, so we're trying to assign these things to a temporary variable. So where do we stick things that are temporary variables? On the stack or in a register? But there's limited registers, so like have a stack of registers? What do you mean by a stack of registers? I'm gonna need a better way to write this all out, because this is gonna be like impossible. Like you only need temporary value for like one specific expression. They're just intermediate values. So just have a stack of registers and take the registers from there. But what do you mean by a stack of registers? You mean just like the hardware stack? Or just have like a fixed number of registers that we use? Nope, like the data structure? Data structure? Mr. Glick gets it. Okay, so make my own stack is what you're saying? That consists of just the registers. And a stack that stores which registers to use next. Yeah, okay. So in which case I'm gonna want some pieces of state, which means these shouldn't just be like these loose. These should be on this codegen thing, which makes more sense, I suppose. So basic block. I'm just gonna rename this to ASM. Well, I guess it does this, no? Okay, so this is better. So we don't need this. And then okay, that should give us the same. Perfect. Okay. So now I can like manage state and stuff on this struct. And okay, so I need some concept of like a stack, or like a register stack. I wonder if I should have some like register. Where are you at with compiler? We're trying to generate assembly now from an IR we made. Enum register. So what are like the registers in? I think I have like a cheat sheet somewhere. Here we go. So there's like RAX, RBX, RCX, RDX, RSI, RDI, RBP, RSP, R8, R9, R10. Very cool. I've seen your videos and I recommended. Cool. Yeah, it's been a lot of fun. R11, R12, R13, R14, and R15. Okay. So these are registers. And then we're going to turn this into I wonder if that'd be better. Yeah, Clippy doesn't like that. Okay. So then how do we make a stack out of these things, right? So we need like a pointer, like a stack index, right? I also tried creating compiler languages, compiling to C, which gets compiled to. Awesome, that's super cool. Is humbleOS fully a mini OS that you're running with QEMU or something? I haven't seen those videos yet, just the thumbnails. Yeah, Humble isn't very far along, because I kind of am taking the long way to get there, right? By making my own language for it. So the development on that is kind of paused while I'm working on this. So, but yeah, it is that I'm running in QEMU and stuff. Correct. Is there a const expert in Rust? I don't know. Yeah, it's a long way. I'm taking the scenic route. Cool. So x86 only? Yes, for now. But I mean, no, long term it'll be, that's just the first one I'm targeting. So, because that's what Humble is going to be. I'm also OS Dev 2. I will be making GDT and keyboard drivers this weekend. Awesome, that sounds super cool. You should get on our Discord. There's a bunch of OS devs there. All right, isn't there like a, what I really want is I want to turn this into like an array, a vec, right? How can I, is there an easy way to make these into a vec? Isn't there like an ordered? Ord. Do I need partial E to be partial ord? I do. So there's that, and then is there a way to turn an ordered enum into a vec of all the values in order? Because what I want is like that, and then which web languages are you good at? Isn't there kind of only one web language? And if you don't count WASM? Surely. Is there a way in Rust to take an enum that implements partial board and get a vec of all the members in order? Okay, but there's no way to do that automatically. That's kind of weird. I feel like they should. So we'll make it then. Let's just do this. And then make a macro. Perfect. Okay. So there's my register stack. Yet another thing to add to Lovely. Totally. Yeah, that'd be cool. Are we ask more comments? There's a crate called strum macros, which contains the enum iter derive macro. You can use it to turn the enum into a vec. Oh, cool. We probably don't want to be using all the registers you've added to the enum for temp values. RBB and RSB, for example, are initiated to be used for stack pointers. Ooh, good point. I forgot about that. So we should take out some that we'll use for other purposes and just use the others for our stack thing, right? Like, isn't RAX used for return values? So which of these shouldn't I use, guys? Okay, this is like return values, right? So I shouldn't use this one. This is the stack pointer. Yeah, and you should also settle on calling convention if you haven't settled on one already. Yes, truth. Isn't this like the base frame pointer? And then, so we'll take out these ones. And then what about calling convention? I should really be putting this up here. So this will be like return values, frame pointer, and this is the stack pointer. And then Any of these I shouldn't use? Is it RDI? Like, aren't some of these for like syscalls and stuff? Well, I mean, they all have their own use, I guess. Yeah, but what about calling convention? What's cdecal? Cdecal calling convention? Is that something I can look up? Cdecal calling convention. Cdecal. Convention for the programming language C and uses many C compilers. You like my names for the OS and language? Thank you. Subroutine arguments are passed on the stack. Are the return values or integer values? So cdecal uses the stack. Hey there, William. What did you miss? We're trying to figure out a calling convention. Function is responsible for clearing it. That makes sense. So then we don't have to worry about like saving any of these. We can use these all for temp values and stuff because then the function calls will just go on the stack. I think that'd be good. So we're not going to use these ones though in our this thing. So these are our like temp value registers. And then I'm curious, what made you want to make your OS and live stream it on YouTube? Well, I didn't start live streaming. I started just like pre-recording videos, and that was really honestly just to keep me motivated. Because like if I have something where I can like look back and like see my progress more easily, and also something that'll like keep me, like if I know that somebody can see this, then it makes me kind of need to work on it more diligently and not get distracted. So that was a big motivation. And then people started helping, but that was sort of like a secondary thing for me. Like that was totally unexpected. I wasn't expecting people to help, but that has been huge. You personally wouldn't use cdecal, rather systemd AMD 64 ABI? Oh dear. Watching your videos is oddly satisfying. That's interesting. I wonder why. Since I'm mostly just kind of flailing around. Well, we don't have to use anybody's calling convention, right? We can just make whatever seems easy and makes sense to us, don't we? Right? I mean, I'm sure there's reasons that people have decided on these things, but I like the idea of just putting all the function arguments on the stack. Doesn't that kind of make sense? You just go, yeah. So okay, so I'm going to make a oops. Oops. Okay, there we go. Without proper calling convention, it creates problems if you want to use some existing libraries. With cdecl, you could skip writing the standard library and use... I don't know if I want to skip writing the standard library. Is this OS project something completely new to you? Yeah, totally. I've never done OS stuff before. Yep, I'm taking the scenic route. I kind of want to write the standard library. Does that sound like a bad idea? Because I want to write it in Lovely. Or at least parts of it in Lovely. Alright, anyway, so this will be RAX, this is RBX, RCX, RDX, RSI, RDI, RBP, RSP, R8, R9, R10, R11, R12, R13, R14, and R15. Hey, good morning, Bacon. Cool. What are you looking at now? Same thing, right? Oh no. We got errors. Oh yeah. Now we're happy. Okay. What are we working on? Yeah, assembly codegen, like, I don't know, bro said. So those are registers. And then this is our, like, homemade, homegrown stack of registers. Yes, that would be great, William. So then I'm going to say what if we... Okay, we need some sort of function method for... excuse me. Shift... Well... oh no, it's the daily freeze. The daily freeze. Alright, ready? Get your timers ready. 3, 2, 1, and go. How do we do this? Video capture device. Okay. Device. This one. Shrink. And then add one of the, this one. This one. This one. This one. And then, oh, I gotta switch this. Okay. Do that, and then make this be the right, no, not that one. Not that one. This one. Switch that to the right size. So it covers me all up. And then, for my next trick, I do this. And then drag this guy over here. And then bring that on top. Perfect. Yeah, Big Micaiah. Am I still playing my banjo? Oh yeah. Banjo's my main instrument, so I play it a lot. Although I haven't been able to practice as much in the last few days as I would have liked, but Kai is massive, but there's something else that's massive? What are you talking about? What's back there? Um, Programmer's famous last word. Oh, okay, I get it. I get it. I get it. I get it. I take it back. I take it back. Um, okay, so let's keep going here. Yeah, how do I wait? Okay, there we go. Right? Yeah. So I need some way. Um, what does TWM stand for? Um, oh, tiling window manager. I'm not using actually one. I'm just using like the built-in Mac OS thing, which can give you like stuff like this, which is like nice enough for me. I've used a bunch in the past, and then I always like I use them 99% of the time. I just want something full screen like this, and then when not, I want it split. And the native built-in one gives me that, and so I just kind of switched to that after a while. But when did Mac get that? Using Hyperland with Arch, by the way. Gotcha. Um, no, Mac didn't get this until like last year, I think. I think this is like the latest iOS, or maybe the one before that got this. It's pretty new. Um, cool. So let's. I need. Okay, so I need to store like which value, right? Like, how do I? I need some like push and pop. Um, right? Yeah. Okay, so I'm thinking, do I need to store? Wait, how do stacks work again? So if I have a stack, I can only like push things to the top or pop things from the top, right? Like I can't pop things from the middle. So this means guys, you guys and your tiling window managers. I get it. I get it. You're all cooler than me. It's fine. I'm here on my MacBook. Um, trying to figure out how stacks work. Does this need to know what like value is stored with this thing? Like, do I need something like a Dude, you're cooler with your MacBook? No way, man. Um, this is so confusing. Cost 20 times more, perhaps, but okay, so the destination, what is the destination? It's an entity. Like, should entities be stored on the stack? So I know, or not. Maybe not. Okay, let's start without that, and then if we need it, we can add it in. Name for I write my own OS, by the way. Me too, I just don't use it. All right. So if we have a, all right, so we need some sort of push thing, right? So move, I'll just name it like shift stack index right. This will take a mutt self, and it'll do exactly what it says. It'll say self dot register stack index plus equal 1. It'll also say if self dot register stack index is greater than self dot registers. These are like temporary. It's like the register stack. Sorry, dot len. I think greater than or equal to, right? Or -1. Then we will panic. And this will say like for now that'll just be a panic, but and then shift stack index left will do the same thing, -1, but it'll check if it's less than 0. Whoa. Oh, this is a U size. So we need to check it up here. Like if it equals 0. I was thinking about doing another stream. Well, that's probably not a good idea. I'm kind of short on time. I was thinking about adding to my stream collection one that wasn't something so difficult. Like me just literally making, I don't know, some like SaaS product. Having some like monetary goal or something. And then splitting it with everybody that helps me. How about that? Nothing in the stack, silly. There you go. Nothing in the stack, you silly. Shinji will invest. Bacon, what don't you study? Oh my word. You literally know like everything. Great stream idea. Remembering every digit of pi. I think I know almost all of them. I think there's like 3 or 4 that I don't know. Pi digits. But I'm almost there. Alright, so now we can shift our stack index around. So when we do wait, how do we know? How do we know what this is? We need a way to, okay. We need a way to like keep track of values and like where they are and stuff. Right? Like how do I do? I know I have a left-hand side and a right-hand side and a dest. I need some way to like look up, like dest can be any of these, right? It doesn't really make sense if it's any of these, I guess. Or this. But it could be a temp or it could be a variable. And I need a way to like look up locations. Like beetles, Lepidoptera, what are those? Cicadas, water lilies, and orchids. You can name almost every single one. Aren't there like 3,000 kinds of orchids or something? No, 28,000. There's no way, Bacon. There's 28,000 species of orchids. Maybe just the local orchids. Also, when are 17-year cicadas due? Wait, 2025? This already happened, and I didn't see any. You know, all the interesting ones. Gotcha. Why are we looking at orchid species? I don't know. It was a distraction. But wait. Something broke in nature because there were no cicadas. And we're past early May. Oh dear. Oh well. Okay. Anybody have any suggestions for how to work this? I'm confused. As I frequently am on this stream. Don't cicadas migrate? No, they like live underground for like 17 years, then they pop up. Well, the 17-year ones do. But we should really ask Bacon, since he's the expert. You have a big book on the North American orchids and Asian orchids, like multiple volumes. That's cool. I saw this really cool orchid book the other day. I forget where I saw it. It was really, really cool. It was like huge and full of like really good drawings. I almost wanted to buy it, and I don't even really care about orchids. Well, I mean, I think they're cool, but they didn't show up in Alabama or Ohio, a little more east and north. Okay, gotcha. Because I remember no, it wouldn't have been 17 years ago. Wait, there were some that were less than 17 years ago here in Ohio. Maybe they're different in different places. In Ohio, we had some like maybe 13 years ago or something, 14 years ago. No, not even that much. 12, 11, 10 or 11 years ago, maybe? It was nuts. There are different broods. Oh, okay, gotcha. But anyway, back to the task at hand. So with temp like, take a register from the stack and use it to store the data. Then when you see it as right hand side, depop the stack. I don't know. Yeah, something like that. Just where do I get, like, what are these? Like, what does this end up being? Left hand side and right hand side? You know what I'm saying? The brood's locations very slowly change over time. That's fascinating. I don't know. Maybe we aren't left-hand side and right-hand side values. They are values. Correct. All right, so I think I have an idea. So what if we, well, maybe not. So what if this stack should have registers and it should really be a tuple? Okay, so what if it's this? Register and temp ID. Wasn't there like a temp ID? Temp ID, temp ID. Haha. Shoink. And then these. Maybe it should be option. Oh dear. Okay, macro time. All right, so there's that, and so then we're going to say here, so right-hand side and left-hand side. I guess it kind of depends what they are. So you tell me we have to match on those things? Something's gonna break, I just know it. Hey, Bacon. You gotta be a little more optimistic, man. So I don't like how I'm about to do a triple match nest. Wait, this is ridiculous. Oh, this is better. You don't see me use inlay hints. Are you blind or do I actually not use it? I pretty much never use it. I used to have a way to turn it on. How do I do it? Inlay hints. How do you toggle them? Like that. Aha. There we go. Yeah. I've just never really gotten into them. It's kind of nice though. I don't know. Just kind of clutters. So for me it's be a space th. So space toggle hints. Space toggle hints. Okay, so let's. All right, here's what I'm thinking. I need a way to get from an entity. All right, I think I figured out a way to do this. So I'm going to say, entity to ASM. Mut self, and it'll return a string, I suppose. it'll take an entity, or a reference to an entity, and it'll say to do. So now we have to do here, all of these are entities. So we don't even have to match on this. This just becomes a lot simpler. We just say how does the add instruction work? Entry foo, there's foo. Oh, we just got some orchid recommendations from Bacon. I will check that out. I'm already pushing in the top. You're doing it twice now into lines. Where? I'm pushing in lines on all of these, but these are all separate lines. You know, I guess it'd be better if there's just like one global lines thing. Wouldn't it? Well, I don't know, maybe not. Would be a good way to do it. Oh, the first two are a moth and a butterfly. There we go. Okay, so then what I'm thinking here is I can just do something like, wait, first remember how add dest source. Oh. Okay, so add just goes from dest to source, whereas we have a right hand, left hand, and a source. So how do you turn? Here's the question. We have something that looks like dest, left hand side plus right hand side. And at the end of the day, when it turns into assembly, we need something that just looks like dest plus source. You know what I'm saying? So how do we say this? We could say like, there's 5 times more moths than there are orchids. Good grief. How do we do this? Say like, we'll say like T1 okay, we can like move into T1 like our left hand side, and then we can add to T1 the right hand side, and then we can move you know, we could skip that last step if we just this does it, doesn't it? So these are equivalent, correct? So this is like our IR. This is ASM. This looks good. So we're just gonna do this. Hold on a minute. Okay. And then this becomes format. What does it become? Move dest left hand side. Okay. So move dest, and this will be ugh. To T dest. What are you? Oh, this used to be mud. That solves my problems. You don't see why we need to move? Because we can't do this. Like, this is 3 values in one instruction, and ASM only supports 2 values in one instruction. So we need to break it into 2 different instructions. And then we're going to add the dest again to the right hand side. Maybe these don't need to be references. How about that? Whoa. We got some issues, most notably this one. Oh dear. Lovely, we got a to-do. Not any of these, it's this one. So this should give us something nice. Look, move, wait, why is it 2 moves? Because this was supposed to be an add. There we go. These really should be indented too. There you have it. So there's that. Should I have, like, should I be writing these raw strings like this, or should I have some sort of like representation like AST for ASM? I don't know, which way? What? Oh, it's this. We did do something, yes. So then we just need a match on Hold on till we make bars work. Yeah, okay. So let's do, sorry. Well, this thing has a value and a type. Let's see if we get enough from the value. All right, so not quite sure what to do here yet, or what to do here yet. I know if it's an int, then we can just do that. What? Now you have to do. Otherwise, we'll just do all right, and then okay. So now we need a temporary value. So what do we do if we have a temporary value? We need to look it up. And if it's a new one, we'll make a new one. Okay, so we're gonna do this. Look up temp val. It'll have self, not self really. It'll return an option of a register. Does that seem right? And then in here, you'll say let foo equals self dot register stack dot find okay. Okay, all right. No. How does this work? Or unwrap or that's what I want. Use size max. How's that? So now we have a say if let sum Can we make these registers be that? Is there a better way to write this? I feel like I could, right? Now we have that. Oh, perfect. So let's return it. Can you destructure in here? No. Okay. Well, there's that. Okay, so then that's nice. Although I wanted to oh, okay, this is not as good as I thought. So else we'll push something else onto the stack and return self dot and do that. Cool. So now we always get a register. Oops, sorry, I just bumped the mic. If there's already a something on in there, it just returns the right register. You think I should rename this? Sure. Yeah, that's better. What are you guys suggesting I do a binary search for? Okay, and then so then here get register, get temp register ID dot toString. This obviously didn't work. These should be the same. It is running twice. Hey, empathy monster. Gotta leave here soon? Okay, no worries. Because when temp value is right hand side, you need to push back on the stack. The register which the temp value took. Wait, what? Wait. I don't get it. I think this would be helpful though if I printed. So and this is Adam. Okay, so there's that. And then I don't quite understand what you guys are suggesting here. So how many times is this being... You use compile, not build? What do you mean by that? This? Oh, you mean for my CLI? Yeah, right now it says compile, but the CLI is not really in a very final state, so yeah, for now it says compile. I'm actually not using just file right now. Build would involve linking as well. Okay. Wait, so why is this being ran twice? Zero and zero. That's what I thought. So why is there... Oh. Oh, because I'm not pushing it onto the thing here. Is that what you're saying? Wait, no. Wait a minute. So looking through the register stack to find one with the right ID. It's not going to find one the first time because there's nothing on the stack. Oh, I'm not pushing it on here. Is that what the problem is? Gotcha, okay. So I just realized that this should start at like -1 or something. Or like usize max. Well, probably -1. I can't compare an I size with a U size? What? Well, really, it should be a U size. I see you, Bacon. Thank you so much. Have a good day, you too. All right, so the shift right thing should say, what's up? We are still working on making assembly, so not much is up. We got the wrong registers though here. This should be the same one. Okay, this should in theory work. And then here, maybe this will work. Oh yeah. RBX, is that our first one? Yeah. So that totally worked. We don't need those zeros though. Cool, this is totally working. All right, so that'll be another thing to try. We could get the arithmetic operators working, right? So like, where's our example? What if we had another line and I was like 13 plus 7? That's not a 7, but you get the point. Cool, so it's using a different temp value. That's great. So if I did 13 minus 4, then we got not yet implemented sub. Right here, right? So how does I think sub works the same way. Sub, same thing, destination source. Yeah, okay, so we literally do the same thing. Just take this out. And then, well, just becomes the same thing with a sub. And then we get a sub here. Pretty cool. And then mul and div are kind of different, aren't they? Yeah, this is the complicated thing. So this uses specific registers. Notably EDX and EAX. But these are what are these? These are portions of RAX and RDX, right? Yeah, so how do I set this up? Like, why does it put the result in, the result in this format? How do you use mul in x64 NASM? Teach me. Yada yada. Source, yep. Operand to multiply with accumulator. Oh, this is what it was showing. But if it's 64 bits, but it is 64 bits. Okay, so it's RDX, RAX. Wait, but what do you mean stored in RDX colon RAX? I think that's for overflow. Load num1 into EAX. So RAX is what is multiplied by it. So we need to move the 1 into RAX. If you multiply two large numbers, the resulting number is like 128 bits. Oh. Gotcha. Okay, so what should I do about that? Because I don't want 128-bit numbers. Yeah, no, it looks like you're right, because EAX now contains the lower 32 bits. EDX contains the upper 32 bits of the result. No, it looks like you're right, doesn't it? This is just exiting. Okay. Mul by num2, which is 10. Saba's right. So what do I do? Do I convert my 64-bit numbers to... Well, I can't really just convert them to 32-bit. Yeah, how do I deal with this problem? I guess we just take the lower 64 bits of the result, and if it overflows, it overflows, right? Yeah, gotcha. Okay, so yeah, what Mr. Glick is saying, just only take the lower 32 bits. So let me... Well, no, only take the lower 64, right? Because I'm doing 64-bit. So I kind of want a 128-bit result, but I'm only going to take the lower 64 bits. Correct? Does that sound reasonable? Reasonable? Or is there a reason why I do the 32? So I'm going to multiply Yeah, which is RAX. Gotcha. Okay. So, oops. We'll do this. So if it's mul, then we have this, right? So we want to do, yeah, lower 64 on Rex. Perfect. So if we have something that's this times this, then we want to, at the end of the day, all we have is mul source, right? And this goes into REX. So then I'd have to then move REX dest, right? But the source is multiplied by REX. We're gonna move move into REX the right hand side, multiply it with the left hand side, and then move into REX. No, move REX into the destination. Does this seem reasonable to you guys? I think this is right. Correct. Or REX. Yeah. Okay. That's a good point, Saba. Like, why they do it like this, but they didn't do it with addition and subtraction and stuff. It is interesting. Make sure RDX doesn't get overridden. Oh, am I using that as a good point? Because I'm using RDX here. So I should maybe... But I might be using RDX as a temp somewhere, right, Saba? So I should maybe push RDX and then pop RDX, right? Does that seem reasonable? Pop after, yeah, I got that. Pop after moving? Why pop after moving? There's no reason to pop after moving, right? I think this is good. Okay, so let's do this. It'll be something like this. Start out with a move. We hard code in REX right hand side. Like that. And then we can get rid of this now and do this. And then push. So this actually doesn't need anything. Actually, we don't even need this. This just becomes push RDX. Right, and then mul left hand side. And then pop RDX. And then move from REX to the destination. That seems reasonable. Shouldn't it be push RDX, move RDX, wait. I'm overwriting it on 165 here. Wait, what? You're saying it should be push RDX. Wait. You're saying, oops. You're saying it should be push RDX, then move RDX. Wait, what? I'm not sure I'm following you, Sub. I think this is good. We move the right-hand side into RDX. Then we save value in RDX because it's going to get over in here. Then we restore it because that's fine. Then the result of the multiplication between the left-hand side and RAX, which now has a right-hand side, right, is in RAX, and then we move. Oh, this should be this, though. Which I already wrote there, okay. I think this is good. So if I do multiplication, like 12 times 11, that's cool. Why are we using RAX even? RAX is what gets multiplied, and it's also where the result goes. RDX is where the overflow goes. So RAX is the lower 64 bits. It's also the thing that before the operation, it's what multiplies with the source. Empathy, are you writing ASM in Rust? Is that like a wrapper or something? No, this was, you mean down here? This is just a comment. And then here I'm just, I'm writing ASM, but it's just strings, so. Oh, you thought RDX stored the result. No, RDX stores the overflow. So we're just trying to save it from this being overwritten, right? RAX stores the result. So now I have that. It's kind of hard to read because there's no comments. I wonder if I could add comments. Yeah, this would be cool. I could do something like this. This is minus, this is times. So now we have nice comments. Oh, this looks funny because we actually are using RDX as the... Yeah, that's cool. Except for these comments, maybe she could use a new line. Hey, what is the language you're making? For what purpose? The purpose is because I'm trying to write an operating system. The language is called Lovely, and I'd like to write my operating system in my own language. But this is Rust I'm writing right now. You really love my editor setup. Also, I moved to Maple Mono now. Awesome. Yeah, I love it. I just switched like a couple weeks ago because somebody in the stream recommended it. Okay. So there's that. Seems simple enough. And then where am I based? I am in Ohio, United States. Northeast Ohio. Sort of. All right, so div There's another. Yeah, so one of these gets the remainder, one of these. Okay, so EAX. Oh dear. Okay. Do you have anywhere more detailed information about your project? I would really like to read about it. Not really. I mean, there's a Discord. If you want to join the Discord, then that'd be a great place to ask questions and stuff. There's a link in the description, but I don't really have like a write up about any of it. There's like a README that's really brief about this language on the GitHub, but that's kind of it. I was thinking about. I started making a video that was like the first 2 months in review, sort of, but I'm not sure whether I'll finish that. Discord is banned in your country. Whoa. What country is that? In Turkey? Why is Discord banned in Turkey? That's crazy. Alright, so I think I got this figured out. So the result is going to go in RAX. So is the what's the top called? What is it? Dividend and the divisor? The dividend is the top one, right? The dividend is also going to be, we need to zero out RDX. Okay. So if I have something like wait. If I have something like this, then this turns into, okay, so I need to move into, I can ignore this whole top line because I don't really care about the remainder. Because 2 girls died because of a Discord mafia? Good grief. You sent me a vid in the server? Yikes, that's crazy. Okay, so how do we do this? Okay, so this is more like top. Well, okay, it is more like left-hand side, right? So we have top. Right-hand side is the top, so yes, we move this into that. And then we also need to, okay, save RDX, whatever was in there, and then move into RDX. So zero out. Isn't there a better way to do this? XOR RDX. Because that would be the upper 64 bits of the dividend, and so we want to make sure that's 0. And then it's going to be divided by whatever we pass in, which is the left-hand side. Sorry, these are not labeled right. This should be left-hand side. And then you multiply by the right-hand side. And then you can restore this. The result goes in RAX. This is good, right? All right, I think that's good. So let me yoink that, and then So we need to do something similar to this, but not quite the same. Starting with a comment. We'll move RAX to the left-hand side, not the right-hand side. Then we save this, yes, and then we do another one where we XOR RDX. Multiply the right-hand side. Then we pop RDX, and then we move. Yeah, that should be good. So now I can do like, 6 divided by 3. Cool. So what I'm curious about is what happens when I do nested stuff, like +2 times 7. That's really cool. So it's sticking the result of this in RBX, and then it's using RBX down here. So it's totally working, right? That's super cool. And then if I were to like change the precedence here by adding a block, it should reverse that, right? Yep, it does. Okay. Then we do 3 plus 2 first, and then that times 7. Well, we kind of had the job done by IR, yeah, totally. But it's still pretty cool. And then yeah, this is great. So what happens if I have a Kai teaches lovely to count, exactly. If I have a function now, where it returns 7. It's not gonna like this. Okay, so I need to, because at first it's gonna trip up on the variable declaration. So let's make a variable declarations. If I have x 2, and then I do x, or x be 4, and I do x plus 7. This should give us 11. Right? Not yet implemented assign. Cool. So now, where do we store variables? Is the next question. Am I in university? Nope, I'm not. Actually, this might be useful. Yeah, so what do I do if I have something like, wait, what do assigns look like? Something like this, x, right? Var equals, source. Just use registers, and if you run out, push them onto the stack. Are you sure? Because that's what I'm doing with temporary values too. Do I treat them the same way? I guess that does kind of make sense. All right, let's try that. Also, I wanted to try something else. check this out. So if I do something like, in theory, if I do something like 2 plus 2 a bunch of times, I'll get like no more stack space errors, right? Not enough temporary registers. So that means we'll have to stick stuff on the stack. But for now, so then you're saying variables are like literally the same? Temp get register. So assign source have a great day. This project seems really cool. I hope everything turns out great. Thank you so much, man. Appreciate that. But I think variables persist between expressions, but temps don't. So somehow we need to know not to clear the variables from registers. Yeah. Yeah, we'll figure that out. For now, I do want to just try this. So instead of like get temp, this will just be like get register, I guess. Well, I'm not sure about that. We'll leave it like that for now. And then this just becomes like this. Right, and then we literally just move the one into the other, right? That's kind of it, isn't it? All right, we have a to-do, right? Sorry, this is the other way around. Move source. No. Moving the destination to source, yeah. Except for we don't want that. And this should not be that. This should be that. That's more like it. So now you have a to-do. Because we're referencing a variable here. Who's a string? Okay. What is foo? So that's the string we have. Okay. Also, assignments could also be not from a var but from something else. I don't know. Can functions in Lovely return L values? I don't know about that, but they can be something besides variables in theory. But pretty much the only other thing right now is like pointer dereferencing, but we don't even have that yet. So I think we can just worry about variables for now. So then all right, so we need a way to store these things. So we're going to say all right, so maybe this should have a different, either a temp ID or they can be variables, right? So I'll say like enum register item. I don't know what to call it. And it'll be either temp value, which holds on to temp ID, or a variable, which holds on to a name ID. Sorry, string. Option register item. And this will take a item, I suppose. If it's a temp value, well, we really want to do like item and R. And this can be a reference. Temp value. Oh. There we go. Then we have this. I guess we could do this. What? Okay, and then places is just to get us true, right? And then otherwise, if it's a so anything else that gives us false, right? Oh, this really shouldn't be that. But okay, there we go. Uh-oh. Maybe we don't need these giraffes anymore. Yeah. Okay. Am I using a split keyboard? I am. Yep. It's the ZSA Voyager. Looks like this. I'm curious how you knew though. So if we have not a temp value, if we have a variable, and then here oops, not item, this should be I was mistyping that as that. Wow, that's quite a thing to notice. Although that's a specific mapping I made. So I'm curious why your friend would have the same issue unless they did the same mapping. And item name equals reg name. Alright, so there's that. The best part about the split keyboard is there's no arrow keys on it. So I literally don't even have an option. Is this right now? I think it should be right. So then here, I'm gonna say that. And then here, why did I do all that again? The only reason I bought one is because I use my fingers a lot. Because one, I'm obviously typing all day long. I'm also a musician, and so I play a lot of instruments a lot. And so I kind of want to take good care of my fingers. And this thing is much better for like wrists and fingers and stuff than a normal keyboard. So I thought it was worth it for me. But what's wrong with normal keyboards? On a normal keyboard, your hands end up doing this, and your wrists are always bent. That's like the biggie. Is like your wrists are messed up if you use one. Like you can't have your wrists straight. Your wrists have to be bent to be sitting next to each other like that. The other thing is your fingers are always reaching for weird things because like all your special characters, especially if you program all the time, your special characters are always like way up with your pinky and stuff. And I have all that with my thumbs because your thumbs, basically both of your very best fingers on a normal keyboard are being wasted on one character, namely the thumb, right? Whereas I have thumb clusters, right? So there's special buttons for each of my thumbs. So I have all sorts of things that my thumbs do that don't happen on a normal keyboard. So you're just sparing some of your other fingers by adding more work for your thumbs, and then you're also like not bending your wrists. So those are some of the big ones. Also, vertical key. It's also faster if you get used to it. Like the vertical key column, so having your keys all lined up vertically like that is just better for typing in general. Yeah, 90 to 100 is good. I'm not saying that like you can't. I think the guy with the fastest thing doesn't have a split keyboard, but just generally speaking, especially it's not even necessarily for like typing words, but more just for like typing, all this kind of stuff that you're always doing in programming. So. Okay, what am I trying to do here? So I need. Here's what I need. I'm gonna say. This. Can I do this? This isn't possible, is it? No. This isn't possible either, is it? Shucks. Let name this can be unwrapped because it should never happen. I'll expect just in case. Those are good errors, right? So that's nice and all. And then can I do like how do you parse a string as an int in oh goodies, parse. Here at Lovely, we really value good error messages. All right, so now we have a name and an ID, so we can say like all right, so this should now work for, what should this now do? Oh, cool. This works. That's nice. And then cool, so now functions would be like the next thing, right? So if I make a not yet implemented go to just ends up looking like this, right? Like jump whoops. Why is the YouTube chat so laggy? You're the only one who's talking? I'm not sure why you're the only one who's talking. Nobody else seems to care. Alright, now I implemented exit. So exit is interesting. Background noise for gaming. That's what you guys use me for. That's funny. So we have an entity. So this needs to be like a lines.push. So this is for x64 Linux, right? So we're going to use Linux syscalls. How do you exit again? Didn't you just do it here? rex60 RDI. Ooh, yeah, move that there. Move RDI. This needs to be and then oops. How about that? Whoa, is it just me or did that just work? Except for that we forgot comments here. This was supposed to be a comment. And then, oh wait, no, there's a to do there. Oh, because it's a function pointer. Goto also could use a comment. And then there, that's very nice. Shouldn't we have used call there? Yeah, except for the main just works differently. Main, it just, because it automatically runs in main. I guess we could use call, but it's the same thing because it doesn't take any arguments. But I guess it might one day take arguments. I think goto's fine for now. We'll stick with goto, but yeah, long term it should be a call. So we just got to figure out what that to do is. Function pointer is this, right? Yeah, it's just that we're just using goto. Goto is just special. Just a special case for the main function, right? But generally speaking, for functions, yes, it'll be call. All right, how do we store function pointers and variables? They're really just labels, right? So how do we store like a label and a register? Dots. I need like a pointer to a label. What is this? Is this a string? Label. Any thoughts, chat? RBX needs to store like what if I make another function that's like calc is a function. Oh, then I'll have to deal with calls. That's probably not good. Well, it's probably fine. Calc, fun. This is get 4. Hey, I'm back. What did I miss since we were talking about 64-bit addition? We've done 64-bit addition, subtraction, multiplication, division, variable declaration, and now we're doing functions. So this is all of our assembly now with main functions and going to it and doing syscalls and executing and stuff. Oh, rat. We're going to use RAX for return values. Right? So if we use... Alright, I'm going to do this, okay? I'm just going to jump the whole way. Get 4. And then this should be 7. When you return, you lines.push comment, right? Which is like return entity. Then you do something like this. You move into RAX and then ret, right? I think that's all there is to it. Gotta say, this language feels like it's moving pretty quickly. Well, maybe. All right, so now call we don't have, right? So call, we need to push everything in order. All right, I'm just gonna, for now, I'm just gonna, what in the world is a callee? Oh, this thing that gets called. Yes, okay. So this ends up looking like I'm gonna save args. For now. All right, and then just joined and it's so cool to see you're there at codegen. Thank you. Yeah, it's super fun. Okay, so saving those, and then otherwise it should basically just call the callee. I'm not sure how that's going to work though. And then move dest rx. I don't need that. See, but this is not the right label. Oops. Working on your language as well, and you don't have an IR. I know it's bad practice, but it's just fine. I've done one. I did like a tiny little toy thing once without an IR, and yeah, it is fun. Yeah, how do I call these things? Oh, this doesn't make any sense here. So that should turn into to do, yeah, right? No, call RBX. This is correct if RBX can be a label. How can I store a function pointer, which in NASM is really just a label, in a register so that I can say call rbx, for example. You can store the address of a label, which acts as a function pointer, in a register by using the LEA, load effective address function instruction. This allows you to later use a call instruction with a register to jump to the label. Here's how I can do it. Oh. Planning on linking with a C runtime for printfs and stuff, or are you going to write your own standard lib? I'm going to write my own standard lib. So this is like what we need to do. How do we get the label? It'd be yeah, okay, so we need like a custom thing. So when we do a definition, I think this is fine. So where's my assign? A source. Yeah, okay. If it's a function pointer, we can do something a little bit different. Otherwise, we could do what we have been doing. This should give us a label. Yeah, and then here we're just going to what are we going to do here? We can you load effective address where you want to put it, your function. Okay. And then how do we do it might be a function pointer which has a label. If it is a, wow, this is ugly. if it's a function pointer, oops. And the labels are the same, then yeah, go for it. And then there we go. So there's that, and then if we have a function pointer here, then okay. Wait, what function is this in? Yeah. Then we want to say okay. So it's like LEA, okay. Label goes in there, right? Yep. And then that becomes dust. And then that should do it. So now we're loading these labels into these things and jumping to fun2. Fun2 then calls RBX, which is this label, which is this thing. So this might just work, as long as hashes are allowed in NASM labels. So what is this? Move T3? That doesn't make any sense. That's a call. Oh yeah, this is bad. This should be so now that should be something not. Yeah, now let's move RSI. Cool, that seems cool. So in theory, this should work. You can't use hashes in NASM labels? Somebody told me that you could. Granted, this is the AI overview. Not sure how much we can trust it. Yeah, let's just give it a shot. Should we try to run this thing? Let me give it like an out. Now we have this. Assembly. It doesn't even have anywhere. Okay, so maybe entry should be called start. You missed most of the stream till now, so forgive my ignorance, but why are not generating call fun 0 instead of... These aren't calls. These are like function definitions. This is a call right here. So we're loading the address. We're loading like basically this label into this so that we can then call it like that. Does that make sense? The LEA is for definitions, not for calls. You know what I just realized though? All these places where I like hard coded those comments, I think I could have done... Yeah, this. And then I don't need that, or 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 that. But you don't need to do that. The assembler knows the address of the fun 0 and will use in the call instruction. I'm not sure I quite follow. Let's make sure that that looks the same now. Yeah, it still looks the same, right? So that's better. And then, all right, so we need to like expose global. So let's do a little bit of extra work here. Where's this thing start? Here, right? And then so it's entry, we're just gonna do that start thing, and then if it's something else, then we will just do other. Okay. Okay, start. I don't know why there's 2 colons after it. Perfect. Global start should have a new line after it. Oh, this should also be section text, right? Hey there, my coding diary. Right? Does a colon go after that? I forget how this works. Section dot text. No, you don't need a colon. Cool. Should we try to run this? What should it do, right? It should exit with code of 7. Right? Exit code. Okay, now I'm going to make a new window here. I'm going to... Do I still have that thing on my desktop? What happened to my hold on. Oh, here it is. It's up here. Goodies, he's still there. Okay. I'm gonna... And then we do Kimu. Is this it? Bro has Arch Linux on his desktop, literally. Shouldn't it be section text first, then start? Does it? Should it? I always thought it was the other way. Arch. Arch. Alright, we're in. So if I go into Lovely, excuse me, and then I like git pull, dubious ownership and repo. All right. Oh wait, I can do this. Ta-da! Uh-oh. What? What is it? How do you install something? How do you install something? So back in SYU. Okay, so I need less. Wait, not SYU, just SY. Okay, because the U will update. Shrink. Okay, and then now I should be able to do this, and then I can't copy one of these. Wait, I need to copy. Okay, I can do this. Ha. 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 All right. Ha. Perfect. Okay. Now what do I do exactly? So now I should have a okay, wait. Where did all this come from? What? Oh. Oh, that worked. Okay. So now this is our function, right? Our thing. Okay, that looks like it. And then this is our, I can't scroll, but okay. So now I'm gonna say nasm dash f elf 64. Joink. What? Wait, how does this work again? I got questions. Oh. Because I need to sudo it maybe? Haha. Guys, it worked. It totally worked. This is amazing. It was supposed to be 7, right? Wait. Right? Because we call get 4, which gets us 4, and then we add 3 and make that the return thing. Why is the 7 outside the window? It's inside the window. The window ends right here. I cannot believe it. This is crazy. Cool. So it's totally running. It's working. Can we make something more complicated? Like, I think I have Vim, right? Oops. Let's sudo vim test.lovely. All right, what should we write, guys? We finally have the power to write humble. We might want a little more power before we write humble, but it's definitely a good start. So we can't do function arguments yet. I think we could have another function like get 5, which is a function that, you know, returns int, and it returns actually 6 plus 2 divided by 4 plus 3, I think is 5. 8 divided by 4 is 2 plus 3, yeah. And then x is get 4 plus get 5. This should give us 9. X plus 1 should exit with 10. Am I right? Do recursion. I can't do recursion because I can't do a base case. Yeah, we couldn't break out exactly. So we'll start with this. It would still work. It would just go forever, wouldn't it? So now I need to... Oh, wait. I have cargo, right? No, we can't register it out yet. Yeah, 1,000 years later. 1,000 years later. Gee whiz, the Rust docs take forever. Rust standard, Rust C. Hello, weird video gamer. Rust format. Here we go. Okay. Now can we try that again? Hoofty. Oh, I need to build it first. Chugga-chugga-doo. I thought we did that. Isn't this installed now? Should work, right? Stable. The default is now this. Default toolchain set to this. But then it says Rostup could not choose the version of cargo to run. Maybe I need to sudo this. Oh, don't tell me you're going to download these all again. Oh, please. Oh, it's going a lot faster, though. Alright, we got some stuff in chat. How do you do this stuff? Because I'm learning C, C++. You said make a language. I want to learn C, C++. Yeah, now we're 20,000 years later. You should not be using sudo. Why shouldn't I use sudo? Pretty sure this is gonna work now. Ta-da! Oh yeah. Linker CC not found. What do I do? Like sudo pacman -s. SYCC. There's no such thing. Whoa. Whoa. I feel like I've gotten this error before. Linker CC not found. Oh yes. Build essential. So I need the GCC toolchain. No such thing. Maybe GCC? Essentials, they're called? Essentials. Nope. Pacman, it's base devil. Base devil? Base devil. Oh, that came up with something. Oh, base and base devil? Should I get base too? Oh, look, installing GCC. Perfect. All right. Coolio, let's try this. Yada da 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 ba doo ba doo ba doo. I honestly can't really believe that that executable worked. Because, I mean, it was pretty simple stuff, but we didn't test anything, and then it just worked. Well, here we go. Lovely itself. One core. No, I think I gave it a couple cores. I don't really remember, though. I think you find out. 2 cores? Is that what that means? Oh dear, what happened to... There we go, okay. Oh yeah, I forgot we're still printing all that out. But that's good. And then... Yes, so let's now cargo. Oh, I did that. So now should be that. This should be, yeah. So this is a lot of assembly. We might actually run out of temporary values. No, I don't think so. We're only going to T10. I think we have T13. So now we just do dash f elf 64 test.asm dash o test.o. What? We got an error on line 39. Why are you building this laying? Learning or as fun? Both. So what's the matter? Line 39, where is that? Here's line 39. Mul 4. You don't like mul 4? Can you not multiply with like immediate values like that maybe? It's not happy about this. Doesn't need a sec. No, mul doesn't take a second argument. Maybe mul can't be used with immediate values. Within literals, like mul 7, or should I move 8 into a register first? imul can be used with immediates. Oh, mul cannot be used directly with integer literals. So imul can. So should I use imul? Otherwise I can use intermediate values, but where is imul? Mul. Imul is not in here. I remember using it in the past though. Asm imul. Let's just use an intermediate value. That'd probably be good, right? What do you guys think? Intermediate value or imul? I say just use an intermediate value. So for mul, so mul here. Okay, yeah. So we need a temporary thing. We'll just use RAX, right? So we'll push RAX, and then we'll move move into RAX the left-hand side, and then we'll mult RAX. Oh wait, no, because RAX has the value in it. We can't do RAX. So we needed to use something else. How about one that, I don't know, R15? Push R15. And then move into R15. Instruction div is using mult as well. Whoops, this is bad. All right, so we move into that and then multiply with R15 and then and then here we need to pop R15 mul. Yeah, that's right. Okay. That should do the trick. Okay, and then jump back over to this guy. Okay, we need to like get shoink, and then all right, change this to our other thing, which was like oh shucks. Get, well, something like this, and then get 5. This will be, what was it? We had like 6 plus 2 divided by 4 plus 3, I think is what we had. That gives you 5. And then here we're going to say plus get 5, and then we're going to add 1, or maybe 3, and then it should exit with 12. So 12 is what we're looking for. All right, and then we do the whole cargo, this guy. Okay. This looks right. Get 4, get 5. Yeah, okay, this is the right thing here. And then we need to elf64 test.asm -o test.o. Error on line 39 again. What do you mean? Oh. So we need to do the same thing for a div. Alright, same thing for div, folks. So after we push that, we're gonna push R15, and then we're going to push R15, and then move R15. Why aren't we using RDX? Because RDX is being overwritten by other things. So R15 is a safe one that's not going to be overwritten. Move the right hand side into there, and then we div with R15. And we don't need this. Or this. And then here we just need a pop R15. That should do the trick. And then here I will get save. So what if it is overwritten? No, because RDX, actually some of the result goes in RDX. Why are you not using LLVM? Because mostly just for fun and learning, and because LLVM is, well, yeah, just I don't know. I just kind of want to do everything myself. But didn't we elect to ignore that? Yes. Maybe we could use RDX? I don't know. Let me try this first. Maybe we'll decide to use RDX. But first, let me try this. So I need to do this dance again. Showing, okay. And then, okay. Okay, now we can, oh wait, we need to do this first, because this is still our other example. This is 6 plus 2 divided by 4 plus 3. Okay. That should work. And then okay. What just happened? I can't type anything. I mean, I am typing, but it's not showing it. But let me try this. Okay, and then try this again. Just using a new shell would have worked. Oh, good idea. I didn't even think about that. All right, cool. That's good. And then hey, it worked. And then oh yeah, ready? Moment of truth. $12. It's totally working. That's so cool. Let's go. All right, for the thumbnail, what should we do? Yeah. For this cat. This is a pretty good thumbnail, I feel like. Awesome, that is so fun. Seems like a pretty good stopping point too. So we officially, let me clean up my Git history because I kind of mangled it. Like to here. E631. These I'm gonna squash them all together. And then rename them to yeah, now you can use lovely as an actual language, William. What else you guys saying? And red clickbait circle around 12. Yeah, that's good. Thumbnail captured successfully. Yeah, that's what happens when you use Mac OS. You already know how types will be handled? Not exactly. Everything is just kind of assumed to be you mean like user-defined types? No, because we're literally just doing ints right now. We haven't really talked much about user-defined types, but what's a good commit message? What is this for? Oh, actual code gen, right? Basic code gen. Now I should have some cleaner history. Yeah, okay. I'll have to force this joint. Cool. I'm gonna write something in lovely. Yeah, you should, William. Let us know how it goes. Are you on ARM? I am on ARM, yep. That's why I'm running the executable on Arch Linux here. So I can shut this down now, right? Shut down now. Cool. And then I can get rid of this. Okay. Anyway, you're gonna try running Lovely? You should. It's all in GitHub. Let me just make sure everything's on there. Yep, 2 minutes ago. Basic codegen. Awesome. All right, well, thanks everybody for all the help. I will likely be, what is tomorrow? Where's my calendar when I need it? Tomorrow. Ooh, I have some stuff tomorrow morning. Maybe tomorrow afternoon. If I do one tomorrow, it'll be in the afternoon. But if not, the next day. So, cool. Thanks, everybody. Until next time. Oh, wait. Hang on. We got a... Weird Video Gamer says, wait, does it have docs? Not really. But it's pretty straightforward, I think. All right, now I'll actually end it. Goodbye, everybody.